Hello, it's Wednesday night and it's time for another episode of Let's Make It. We're going to have a little bit of change tonight. Last time on Let's Make It, I said I was going to talk about like reading sensors, things like that. I'm actually going to change up. After I thought about it, you can read the sensor, what are you going to do with the data? So actually, I'm going to tonight talk about LCD. So when we read the sensor data, we have somewhere to display it. So it'd be a little more helpful. You see I'm in the studio by myself tonight. I have the camera set up right here and I have an Arduino sitting down right here. And we're going to go through and show you how to easily use an LCD. In fact, it's so easy, I think it's more difficult to actually get it wired right. And the wiring is really simple too. In fact, I've actually done a schematic and I'm going to put it out in the show notes so you can download it and make sure you get it wired up just right. And you're going to see what I have. It's going to look a little scary when you first see it. And I'm going to explain a little bit of that and a couple of things I'm doing a little differently than the default Arduino configuration if you download the samples. And their wiring diagram for their samples, because the LCD I'm using actually is backlit. I was using a non-backlit LCD. When I got in here in the studio, it was too hard to see with all the lights that are in here. So I went and got a backlit one and configured it. And it's actually pretty much, I'll show you the LCD. I'll pull one off and put the other one on. You'll see that they both work really simple. So let's go to look at the configuration, what we're going to be working with tonight. And let's see. Too fast at it. All right, so I'm going to zoom out here a little bit. If I can find a zoom, wrong way. And what you see here on the desk is an Arduino, and this is the Leonardo Arduino. We got this since our last recording, so I've been using it just to get familiar with it, and it really is not much different than used in the other ones that we've had. The thing you got to make sure is when you're writing code for it that you change in the configuration of the software which board you're talking to. It took me a little while to remember that, and I couldn't figure out why it would install and compile and install, and that's what it was. So what I have here off of this is wires going to a small breadboard, and I have a backlit LCD. So when I zoom in, you'll be able to see a little better than what it is right now. I also have with me right here the other LCD that I was using earlier tonight. But as you can see with the glare, it's a little hard to see what it said with all the lights that are in here. So I decided to use the backlight one just to make it a little bit easier to see. And I will put that on later on. You'll see I can pretty much swap them out. There is 2 additional components needed for the backlight. And I actually put that in the schematic drawing as well, just so you have a copy of it. So I'm not going to focus much on the Arduino tonight on the actual board. I'm going to focus more on the display and the code on the computer. So I'm going to zoom back in. And while I'm doing that, all right, so okay, there's a little closer, see if I can get it squared up. So you see I already got a little small program running, and basically this is an 4 or 8-bit LCD. I'm running it in 4-bit mode, which means I basically have 4 data wires, and then there is the power and ground over here. And you see this little potentiometer. This is actually used to adjust the contrast, and actually have a little screwdriver here because the 2 different LCDs are different from each other. So you see if I come down here and I adjusted this is adjusting contrast. So we'll try to get it so you can see it. Oops, it popped out. All right, so you see a little wire going from here, which is actually going to ground, and then you have a diode here from positive or plus 5 volts going in, and that's actually what's running the backlight. In fact, if I pull this out, it's going to cover it up. If I pull this out, you can actually see that the backlight goes away, and you can barely see the words that are in there. So the other LCD I have is not backlit, so those are 2 additional components. I did include them in the schematic in the little note next to them saying this is optional. It's not needed on every LCD display. So basically what it takes to run it is 4 data, power and ground, and then you have a select, which basically turns the display on and off, and a clock, which is every time it has new data to send out, it sends the clock, lets the 4 bits go in. This LCD can also do 8-bit. I'm going to run it in 4-bit mode, which gets you most of the characters that we use every day. If you're looking for extended characters and stuff like that, then you need to go to the 8-bit. Now the Arduino can do both 8 and 4-bit. I'm just going to run it in 4-bit for tonight. So what I want to do real quick is I want to show you the schematic that's going to be on the site you can download. So this is the schematic right here. And it's really pretty basic. What you basically have is the display, and this is the pins that you hook up. So here's your ground, here's your plus 5 volts, so your ground in VCC. Then this is the contrast, which is what the little potentiometer was I was spinning. And it basically is a 10K potentiometer that I stuck in here, and the output goes to the contrast. You have your RS, which is your clock, and which goes to pin, I have it configured to go to pin 12 on, pin 12 on the Arduino, and that's actually the default. If you download the projects from the Arduino website, that is the default setup pin. I kept everything the same, so if you wanted to take this drawing and wire it up on a breadboard, you could just download the sample programs. In fact, I'm going to show you the sample programs tonight and walk through them and explain what they're doing. And it's when you're going to see how simple this always really is. You're looking at the most complicated part right here. Then you have the enabled, which is the E, which is digital pin 11 off the Arduino. And then you have your 4 data. Now, when you're using only 4 bits of data, you use the upper 4 bits. So you have D4, D5, D6, and D7. And they are going to Arduino pins 3, 4, 5, and 6. So if you're using all 8 bits, you'd have to expand this out to be D0 to D3, and it would take more digital pins than what are currently in use. So it basically would be 0, 1, and 2. You have to figure out where to get them all from. It really depends on which Arduino you're using. Now, you also see these last 2 where it says not connected. I actually connected them up in this drawing because this is what you have to do with the backlit LCD. And all it is ground going to the last pin and a diode just for to keep everything clean going into the next to the last pin, which is pin 15. So that's how simple it is to wire. And I can tell you, it's even simpler to program. It's so simple. I've never actually done an LCD on an Arduino until just the other day. And it's really, compared to what it is doing on a PIC or something like that we use, this is much simpler. And it does everything for you. All the features of scrolling, it's all built in. So let's go back over to the display. And so right now I have the default program running. And what I'm going to start with, the common HelloWorld, which what everybody starts out with when they're programming. So I'm going to get up here on the screen real quick, and all right, there's HelloWorld. We're going to walk through it, and we're going to talk about what each of the options does with the LCD. And I'm going to guess this HelloWorld program, which I'll load here in a second, is actually probably only, well, actual code is probably 11 or 12 lines. There's comments in there as well, but we'll go through that stuff a little bit later. So let me switch over to the computer. Let me see what I got up here on the screen. Okay, so let me make this a little bit bigger if I can. Go to my preferences. All right, now you should be able to see that on the screen a little bit better. So this is actually the default HelloWorld program. It actually comes with the Arduino. It's in the library when you first get it. You can download it from the website. If you go up to File when you're in the Arduino program and go to Examples, and then go down, go to Examples, and then come down to Liquid Crystal, you're going to see HelloWorld right there. So that's what we're looking at right now is HelloWorld. And in the very beginning here, it tells you what pins hook up, which is what I did in the drawing. I'm going to keep the pins the same for all my stuff, just so you can easily download sample programs and play with them. So like I said, RS goes to pin 12, the enable pin goes to pin 11, and then your datas go 5, 4, 3, 2 in reverse order. And then on the LCD, there's a RW. You can set it to ground. It's no, unless you want to be able to control that, but in most cases, you just want to go ahead and put it to ground. And then this is the 10K potentiometer. So it basically goes to 5 volts and ground, and then the swiper, or the wiper, what they call it wiper here, the swipe, goes to pin 3, which controls the contrast. So They give you little instructions right there. It's basically the same thing that I drew, plus I drew in 2 additional wires for the backlit LCDs. So most important is you have to install, or you have to include the library for liquidcrystal.h. So it's real simple. It's just #include and in brackets liquidcrystal.h. Then to initialize the class or the library, they call it a library, I call it a class. You basically put the word liquid crystal, a space, and then what you want to call the liquid crystal display. And then there are pins here, pin numbers. So what the pin numbers are for are, the first one is the RS pin. The second one is the enable pin. And then you have 4 pins of data. If you were using an 8-bit, you basically would put in the same information and then you would include 8 numbers or 8 pin numbers here. So it's flexible. There's nothing else to do other than include 4 more pin numbers. So that initializes the library so it knows what pins to use for the LCD. Then in the setup routine, you got to tell the LCD what size it is. So you do lcd.begin and you tell it how many columns and then how many rows. Now I want to say one thing, that this library to me is backwards. I have a hard time keeping it straight in my head because normally you go row column. This goes column row, and you're going to see that the whole way through all of our examples that the first parameter is always column, second parameter is always row. So what we're saying here is the LCD is 16 characters in width and has 2 rows. And that's exactly the size of the LCD display that we are going to play with here. So the next line does an LCD print and it says hello world, which that's what we want to display on our display. So in the loop, what they've done is they have done a LCD set cursor. And remember, it's column row. So it's column 0, row 1. Everything starts at 0. So basically the second line of the display. And then they want to print how many milliseconds divided by 1,000. So basically it's telling you how many seconds since it was reset. So what I'm going to do is I'm going to publish this, and then I'm going to switch over to the board. So there goes the run. Here's the board. There it is, hello world. And you see it's counting up how many seconds at the bottom, and it'll just keep going. It won't stop. So that's what our little program, hello world program, does. And you saw it's very, very simple. You initialize the library, you tell it how big it is, and then you start to print. So let's go back and look at that real quick again. So here we are. You see the initial setup. We basically told it how big it was, said hello world, and then every time it loops, it is basically drawing a number of seconds at the second row. And again, remember, it's column row, not row column in here, because that'll get you every time. All right, so let's go look at a different program. Okay, so we're going to go finally get into the display. And we're going to show you basically how you turn the display on off or make it blink. There's a couple of things you can do with that. Again, this is a program that's included on the Arduino website and in the Arduino software in the examples. And let's go look at this. And you're going to see, we're using the same wiring because the wiring is the same for all these programs. And you're going to see we include liquidcrystal.h, which includes the library. And we define it the same way we did before, where pin 12 is RS. Pin number 11 is enable, and then we have our data pins. And we're using the same 16 column by 2 row display that I had before. And I'm going to do hello world again. But this time in the loop, what I'm going to do is say lcd.noDisplay. What that's going to do is turn the LCD off. It's going to wait a half a second and then turn the LCD back on again, wait a half a second, and it's going to continue that forever. So this is how easily you can take and turn off, which causes a blinking effect, kind of. So if you want to get somebody's attention, this is something you can do. One thing to remember, though, is this turns the whole LCD off, just not a certain area of the LCD, which you're going to see here in a second. So let me go ahead and I'm going to load this one up, and then we're going to look at the board. So there it's loading. Here's the board. There's hello world, and you see it's blinking. So that's how you turn things off and on. Again, this is going to affect the entire display, not just a single row. So that's an important thing. It's something to remember. So let's go back to that real quick and look at it one more time. After we define our LCD and we print hello world, in our loop, we tell the LCD no display, which turns it off. We're going to wait half a second or 500 milliseconds. Then we're going to say LCD display, which turns it back on. And then we're going to wait half a second again. And then at that point, we go back to the top of the loop and we disable it again. And we just keep on doing this around in a loop. So that's how easy it is to turn off and on the display. So let's go look at another one. Now we're going to show you how to make a cursor on the screen. And this is something, let's go look at what we have here real quick. Actually, let me go load up HelloWorld just so we can have something that's not blinking on us. So there's HelloWorld. All right. So one of the things that you'll notice is there is no cursor on the screen. And sometimes if you're taking input from somebody, you want to show them where they are going to be typing. So the Arduino library has the ability to turn this on real simply. So let's go back over and we're going to look at what's called Blink. It's another sample program you can download right from the Arduino website, or it's right here in the Arduino software. And I'm not going to go through this in great detail again, but here's the include for liquid crystal. We define it right here. We define the size of it, and we basically give our hello world. So now in the actual meat of this program, in the loop, we're going to tell it no blink, which is the default. And then we're going to wait for 3 seconds. And then we're going to tell it to blink, and we're going to wait for 3 seconds. So what we're going to see is 3 seconds of a cursor, 3 seconds of no cursor. So this will give a demonstration of what it looks like when the cursor is turned on. So this is just to demonstrate that. You could always just turn it on in the setup, and it would always be there that way, if that's something that you're going to be using the input for. So let's go ahead and load this, and we're going to hop back over to the Arduino. All right, so here's the Arduino. And right now it's in the 3 second wait. Okay, there's the blinking cursor. 3 seconds, and it goes away. In 3 seconds. So you see it's going to keep going back and forth. So that's what the blinking cursor looks like. So if you are doing an input and you want to show somebody where they are on the screen, that's how you do that. And you can also, what's coming up here, we're going to show you how you can set the cursor location. We kind of showed that a little bit already in the hello world, but if you want to put the blinking cursor at a certain location, you could just use set location. Okay, so let's go back over and we're going to look at the next program. Okay, so we're going to do a text direction. And basically what that says is, what direction do you want the text to type on the screen? Now this is really small. Let me go change this so that it's readable to you. All right, so you see that this starts out exactly the same as the other ones. Let me get down here so you can see that. Basically, define, include, define, and what we have in here is we're using a character to demonstrate the type 1, basically. In this setup, we do the LCD begin, which tells us its size, and then we do the LCD cursor, which we just discussed. So you're going to have a cursor on this example. Now we look at the loop right here, where you're going to change directions from right to left when we hit M. And we're going to reverse again when you hit S. And you're going to go back and start all over again from the very first beginning of the line when you get greater than Z. So what this is going to do is it's going to draw on from left to right up to M. And then when it hits M, it's going to reverse the type 1 direction from left to right. I'm sorry, from right to left. So when it hits M, it's going to start going back to the left. And when it gets to S, it's going to go left to right again. When it gets to Z, it's going to start all over. It's going to go to home, which is the same thing as doing the set cursor to 0, 0. Home is what that it does. It's a shortcut for it. And when it's greater than Z, it's also going to put it back to A and start all over again. And then at the bottom down here, it actually writes the character out, and it does this once a second and increases the current character by 1 every time it does do the write. So I'm going to load this up real quick, and we'll come back to this and we'll walk through it one more time after you see what it does. I think that'll make it a little bit easier to understand. So let's go ahead and publish this, or push this out. It's uploading. It's done uploading. All right, there you go. So like we said before, when it gets to M, it's going to reverse itself. So J, K, L, M, now it's going to go back, N, and then when it gets to S, it's going to go to the other direction again. And then when it gets to Z, it's going to go back to home and start all over. All right, there it's home, and it's going to do it all over again. So let's go back. Now we see what it's going to do. Let's go back and look through the code one more time. I think it'll make it a little bit easier to understand exactly what it's doing. All right, so in the code, we have, I'm just going to focus on the loop section right here. And basically what it says is it's going through this loop. When it first gets to the loop, and the program first starts, we've already set this character equal to A. So it's not equal to M, so it's going to skip past that. By default, it always goes left to right. That's how the default for the LCD display is. For the LCD library, always displays left to right. So it's not going to hit this one because it's not equal to M. It's equal to A right now. And it's not equal to S, so it's not going to do this. And it's not greater than Z, so it's not going to do this. What's it going to do? It's going to write out A. Delay 1 second. It's going to make A equal to B and come back up here again. And again, we go through this whole loop and nothing happens. And we keep doing this the whole way up till we get to M. When we hit M, we're going to tell the LCD library that we want to now type from right to left. So we tell it lcd.right to left, and then we come on down, and it doesn't meet the other criteria here because it's equal to M. So the character is equal to M, it writes out M, makes it N, comes around again, and it's basically going to move the cursor to the left, and it's going to put out an N. And it's going to keep doing this, so N, O, P, Q, the whole way up to S. And when it hits S, what we want to do is we want to turn it back to left to right, and echo out S, and it's going to go T, U, V, W, X, Y. But when it gets to Z, it's going to go to the whatever's above Z, which I think is capital A, I think. And when it does that, it's going to say, well, you're above the lowercase z, so I want you to go home, which is 0, 0. Then I want you to make this character equal to A. And then it comes down here, it writes out A. So it starts at the beginning again. And it goes through this loop forever, for as long as we let this thing run. It's just to demonstrate the two different directions you can type onto the screen. All right, so let's look at the next one. All right, so this last one we're going to look at today is AutoScroll. And this is an interesting one because it allows, when the page gets full, basically to loop or to scroll left to right. So in the beginning here, we do our same normal thing. We include it, we initialize it, we set it up its size, and then we're going to put our cursor at 0, 0, which is the same thing as doing home. So we could have done lcd.home here, and it would have been perfectly fine. And then we're going to print 0 to 9. So we're going to print the character out 0 to 9, and we're going to delay, and then we're going to change the cursor position to the second row, the 16th character, and we're going to do 0 to 9 again. Now I'm on a 16 wide LCD display, so when I get to my second character, it's going to have to do something with that. So what we have told it to do right here is AutoScroll. And what AutoScroll basically says is move whatever's on the screen left or right as needed. So what's going to happen is what we put out in position 0 up here is going to get pushed off to the left, which that's why it's called AutoScroll. And then we're going to turn off AutoScroll down here, and we're going to clear it and do it all over again. So let's go watch what it does, and then we'll come back and look at the code a little bit more. So I'm going to go up here, and I'm going to upload it. All right, let's see here. Maybe it didn't take. Let me do it again. There, it's uploading. Okay, there it goes. Almost done. Hit the button. All right, so now we see up through 9, and now we see up through 9, and you see how it's going off the screen. So what this is happening is it's scrolling to the left. So that's what's called AutoScroll. There are other ways you can scroll. I'll see if I can find the program in here. Maybe I don't know if it got open or not, but it allows you to scroll left and right, move things left and right. So if you didn't want to lose the data going to the left, you'd be able to scroll both directions. In this case, it's actually losing the data going left to right. All right, so we see what it's doing. And let's go look at the code and we'll walk through it one more time. Okay, so here we are in the code, and we are only going to concern with ourselves with the loop again. So at the first time through the loop, we set cursor to 0, 0, and then we draw the numbers 0 through 9 on the screen. And we wait, half a second for each one. And then we come down, after we finish that loop, we move to the second line, and again, this is backwards. So remember, set cursor 16.1 is row 2, position 16, which is our last position on our 16 character display. So we also now turn on LCD AutoScroll, which means that it will scroll. And then we do 0 through 9 again, same loop. And then we turn off AutoScroll, we clear the LCD, and we do this all over again. So this is a demonstration of basically 2 commands, AutoScroll and no AutoScroll. Okay, so let's do this real quick. Let me see if I can find the other program that does the full page scroll. I think I saw one of those in here. I think that's text direction. Scroll, I think it's just scroll. Let's see what this program does. Yeah, this is what I'm going to do. Yeah, this is it. So this is actually telling it to scroll display left, and what it does is it scrolls at 1 position left. So let's go through this real quick, and I'll run it and we'll come back to it then. So what it's doing after initial setup here is for 13 positions, 13 times, it's going to scroll the display left, and it's going to wait for 150 milliseconds. So it's a little bit more than 1/10 of a second. And then it's going to scroll 29 positions to the right. So the question is, where do they get 29 from? Well, I think it's just a random number. It's not, if it was to go back twice as far as it was before, it would be 26, but they're going a little bit farther to show you what happens. So here they are, scroll display to the right, which basically takes it back 13 to where it was, and then goes an additional 16 path to the right. And then we come down here and you see it brings it back 16 by using scroll display to the left. So it's going to take the words hello world, scroll them to the left off the screen, and then scroll them to the right back on and back off the screen again, and then back on again. And then it's going to wait a second and do it all over again. So let's go run this. All right, there you see hello world. You see it's scrolling off to the left, scrolling back on to the right, off the screen, and then back to the beginning again. Then it's going to sit here and it's going to wait for 1 second, and it's going to go back and it's going to do that all over again. So this is how you can scroll the whole page. And you're not losing data when you do this. So if your page is bigger, you can scroll left or right and not lose, like the auto scroll where it was taking it off to the left edge. Okay, so that is pretty much all I was going to cover this week on LCD. There's plenty of resources out there that are online and also that come with the Arduino. So go out and download those, or if you have the Arduino software, it's right there in your examples. Now, one of the things I want to talk about a little bit is we're going to do more with displays probably later on. These are basically text displays. They're not fancy or anything like that. But there are other displays that we have here, and I actually got a couple of them with me. It's a little bit bigger display. This is still just a text display. It's a 4-line text display, and we'll play with that some as well to show you 4-line. And then there are graphical displays, which are like this, even a little bit bigger, but these do more than text. They can actually do pictures and other things as well. So we're going to play with some of those as well. The difference, main difference in these two that I haven't quite figured out yet, and I'm going to try to spend some time on it, is these do not use parallel data. So it doesn't use 4 pins for data. It uses 1 pin for data. In fact, if you look on the back of this one, this is the text only one. I have 4 pins on the back. They're right here. Actually, let me go to the camera and you can see. You can see right here on the back, instead of having all those pins, I have 4 pins, and I have ground, I have VCC, I have SDM, and SDA, and SCL, which basically is data. So data and clock, and power and ground. So I have 4 pins that I transfer my data across. Now, I experiment with this a little bit, and it's not as simple as it seems it would be. The libraries in the Arduino that come with the Arduino appear to only support parallel. I haven't quite figured out exactly if there's another library or if I have to create a library, so I'm going to experiment with that some. I also did not find any libraries for dealing with graphical LCD displays. So that's another thing that should be fun to play with. Some people may already have a library out there. I just haven't found it yet. And to be honest, I haven't really gone and looked for it real hard yet either. So that's something that I'm looking forward to playing with in the future. Now, the other thing I want to show you is, in the simplicity of this, was I had this other display right here that I said I used when I first came in here, and it was a little glary. So I want to show you that if you get these types of displays that are the parallel, the 4 and 8-bit displays, they are pretty much interchangeable. In fact, this is a display that actually came from one of my PIC test projects. So this actually wasn't even designed to work with the Arduino, and it just plugged right in and worked right off the bat. So it was real simple. So what I'm going to do is I'm going to turn the camera back on the Arduino and tell you a little bit what I'm doing to show you how simple it was to just use another LCD display. All right, so here it is, and I'm going to first of all disconnect the power from the display backlight, because this other display has no backlight. So I pulled that off, and I have a jumper pin right here. I'm going to go ahead and stick it in. Just like that. And then I'm going to plug this in. And did I get it? All right, so one thing that you're going to notice right away is the display isn't functioning, and that's because it hasn't been set up. So the Arduino library does this all for you. So I'm going to go ahead, I'm going to reset the Arduino by pushing the reset button. And there you go. I'm not sure you can see that on the camera or not because of the glare. But it says HelloWorld and it's doing its little scrolly thing. So actually it doesn't look really good with it scrolling. The LCD, most of the LCDs don't look real good when they scroll like that. But you can see that is the HelloWorld program that we were just playing with. So that's how easy it was to change out the display. Different manufacturers. One of them I have had for a long time. Actually, the one's on here right now I've had for a long time. When I was first learning PICs and how to program displays. The Backlight one, I haven't had that nearly as long. In fact, it's probably not even a year old yet. But it is truly interchangeable. These LCD displays are pretty common and very neutral as far as their design. They all pretty much follow the same pinouts on the back and everything. I mean, it doesn't. If you find one that's parallel, you're probably going to find it works okay. I have another parallel one that I can't find. I was looking around for it, but it actually is a 4-line display. And if I find it, I may just go ahead and try it real quick and see. Unlike this other 4-line display, this one right here, that's serial, it should just plug in and work. And with the PICs, you can pretty much swap them out. The pins match up and everything. So I may see if I can try to do that. And if I can find it around, I will maybe do a little short video and just show you it to you working. So that was pretty much all I wanted to cover this week. Not a very long one, and actually it's a very fun one for me. And I think it's very important that I did change around what I was going to do order-wise, because once you start working with other inputs like temperature sensors and things like that, I want to be able to display on the LCD what the temperature sensor is reading, and you get more information. And also going to show you how you can use an LCD to help debug problems that you're having. So it's a nice little piece of hardware to have around. I have ordered a shield that supposedly works on the Arduino that is an LCD with buttons on it that may be a little bit quicker for debugging things. I haven't gotten that yet, but it's just basically the same type of thing. We use the same LCD library. So if that's something that you are interested in just for mainly debugging purposes, then maybe the shield's a better way to go rather than a wired breadboard like I have here. This isn't very durable for moving around and debugging things. So a couple of housekeeping things. We record this show on Wednesday nights, typically about 7 p.m. If you get into the live stream, you get a little bit early. We're going through sound checks and checking everything out, making sure all what we had planned on still does work, and things like that. So, and you can join the chat room, which I have people in the chat room tonight, kind of making fun of me earlier as I was going through having some problems with a computer. So I would love to see that, and you can ask questions in the chat room. So far I haven't had any questions. If I did, I'd be answering them right now. But if you go to techzen.tv, you can watch us live. You can join the chat room live. If you like what you're getting here on Let's Make It, subscribe on YouTube if you're watching on YouTube. But we also make it available for download on iTunes and all the other podcast directories. We're even on TiVo now, so you can go subscribe to those and get regular updates. If you follow us on Twitter, it's automatically going to tweet out when we put new episodes up as well. So there's many different ways. We've even created a new Google Plus community for all of the TechZen shows. And speaking of all the shows, we have other shows, and we're adding more all the time. So come visit us at techzen.tv and check out the other shows that we have online as well. We'd love to get you on and interactive in the community with all the other shows that we have. They're all obviously by the name of the domain TechZen. They're all technology shows, or technology related shows, I should say. So yeah, we'd love to have you come out and sign up. Also, if you like it, pass it on to friends. We get the word out that we're starting to do all these podcasts and having fun doing it as well. And I hope you have fun playing with the Arduinos. This is, like I said, like a hobby to me, and this is a show that I want to do just because it's like a hobby to me and very fun for me. Things to do that actually are very relaxing. And that's why I don't mind doing the show completely by myself. Maybe sometime I'll actually bring other people in to talk as well. So, all right, well, that's it for this week. Next week, I think I'm going to go back to the sensor idea and show what sensors can do with the Arduino. The Arduino actually is very simple to use with sensors. It's amazing how simple a lot of things to do on the Arduino are. And then after that, I had a couple of requests. Well, actually, one of them was something that I'm already working with, which is Zigbee. And it's using the XB. I actually have the XB radios, and I'm using them for another project. So we may even do some little examples of simple chat programs and ways for Arduinos to communicate wirelessly with each other without using Wi-Fi, using basically Zigbee or short-range protocol devices like that. So that's all coming up in the future. That's it for this week. All right, have a good week, and go get some of those Arduino stuff and start playing with it. And I'd love to see if you have something you want to show us or tell us, send us a video. So record a video, stick it on YouTube, show us what you created with your Arduino, and then send us a link to it. I'd love to see what you guys are working on out there. All right, we'll see you all next week.